So here's our simulation again. It's not running, but what it has is three atoms. Two of them right here, the red and the blue, are bonded together. The green atom here is not bonded to the other two. When I start it up, they'll be just moving around in this box. So they represent a molecule, a diatomic molecule, and an atom that are part of a gas of three atoms in a box. The thing I want to show you by watching this simulation is that energy is conserved. There are various kinds of energy. Energy can go from one kind to another. One energy system can gain energy, another lose energy. But the total energy of the universe is a constant. And in this case, our universe is just this box, because in this case, I'm not going to add heat or take heat out. I'm just going to watch it go. So we'll watch what happens in this box. What we'll have, of course, to think about is thermal energy and bond energy. We have one bond. The two atoms at the beginning are bonded. When they're bonded, the bond energy is low. If we want to break the bond, we'll have to add energy. That energy will have to come from somewhere. And since the thermal energy, the motion, how fast these atoms are moving, is related to the thermal energy, we expect that the thermal energy will go down if this molecular bond is broken. Okay, so let's start it up and just watch it go and see what happens. The diatomic molecule, you can see what it does. Because those two things are bonded, they bounce back and forth as if they were attached by a spring. They also rotate, and they fly through the air like that other molecule does. So their speed is made up of both rotation and the moving through the air. You can see that I guess I would consider both of these, the molecule as well as the atom, as moving along fairly quickly. Maybe call that a high thermal energy. And there's a low bond energy because this bond is made. Clearly these things are interacting with each other. The green atom is now moving slowly, the other ones are moving faster. Energy gets exchanged. Eventually the green atom will be moving faster, and we'll see what happens to these others. They hit each other. The green atom's now moving faster, so energy got transferred to it. And now energy got transferred away from it. So it's moving slower. Now it's faster again. Basically, this is what happens in a gas. Molecules in a gas bounce around, exchanging energy. Sometimes they're vibrating a lot, sometimes they're vibrating a little, sometimes they're rotating fast, sometimes they're rotating slowly, sometimes they're moving fast, sometimes they're moving slowly. That one was rotating kind of fast there for a second. But the bond has been there the whole time. At no point did one of the atoms move without the other one moving. Now, that's not true anymore. Somehow the bond has gotten broken. So where is the energy gone? The bond energy, to break a bond, we must have had bond energy go up. So the thermal energy, the speeds of these things must have gone down, and I think it's pretty clear that they have. Everything's moving slower than it was. If we could form the bond again, that might be some trouble unless there's an interaction between these. Might be hard to get those things bonded again, because to form a bond, we have to lose bond energy, and that means they're going to have to be moving faster again. Yeah, I think we have. So that now they've formed a bond. Bond energy went down, and so thermal energy went up. And so the molecule and the atoms are all moving faster than they were. So I haven't added energy or taken energy out. What we saw was thermal energy go down and bond energy go up when a bond was broken. That energy had to come from somewhere to break the bond. And then when we remade the bond, the atoms started moving faster again because the bond energy that we lost when we remade the bond went into kinetic energy, went into thermal energy. Okay, now we've broken the bond again, and now they're moving slowly again.